Welcome Math 107 students to lesson number 25, rational functions. This will be our first day on rational functions and their graphs, and it corresponds to section 3.5 in your textbook. So we'd like you to take a look here at this graph of the function f, and we're going to ask you a couple of questions. So take a few minutes there and look over that graph. It's probably a little different than what you've seen in the past. This wouldn't be considered a polynomial graph because of this jump from here to here, this gap. Okay, so this is not what you've been looking at over the last few weeks. So the first question asks us, for what values of x is the function undefined? So I don't know where your eye goes to immediately on this graph. My eye actually goes to two places. One place that it goes to is this dotted green line right here that my graph is approaching. It's getting closer and closer and closer. It looks like it's not going to touch it across it, and that's when I'm to the left of one, and when I turn to the right of one, I'm really close to it also. So at that point, something interesting is going on. So at the point x equals 1, I do not have a value of x for which my function is defined. The other thing you may have noticed is that hole right there. There's a hole in the graph. Makes me want to sing a song. Hole in the graph. Okay, and the hole occurs at what x value? X equals 2. So at x equals 1 and x equals 2, my function is not defined. The other two ideas that we'll be introducing you to today is this idea called a vertical asymptote and a horizontal asymptote. We've actually already seen the vertical asymptote. That's this vertical line right here that goes down through 1. And a vertical asymptote is a vertical line that the graph of f approaches but does not touch and does not cross. So if we recall our information about linear functions, we know that the equation for a vertical line is always x equals a constant, and in this case it's x equals 1. The horizontal asymptote is a horizontal line that our function approaches way out on its far ends, way out at positive infinity and negative infinity. And depending on the function, we can sometimes see really quickly without x having to get too large in the positive direction or very small in the negative, where that function is starting to approach what horizontal line. So in this case, the horizontal line we write as y equals a constant. In this case, our x-axis is our horizontal asymptote, and its equation is y equals 0. Okay, so it's the horizontal line that the graph approaches as x is moving out towards positive infinity and negative infinity. Okay, so that's the preview exercise. Let me know if you have any questions. Send me an email, and I'll be glad to respond.